This is part 4 out of a 4-part video series showing how to use SolidWorks Motion to simulate a packaging machine. In this part, the final event-based motion study will be shown. Start SolidWorks and open the assembly that was created in the third part of this series. The finished assembly can be found at the bottom of this post. Make sure that SolidWorks Motion is added in. Click the Motion Study tab that was created in the last part. The delay for the second task should be 0.72 seconds. This was calculated by first determining the time it takes for the box to be centered underneath the plate after the sensor is triggered. The box needs to travel 6 inches in order to be centered. This is because the sensor is centered underneath the plate, so the box needs to move half of its length once the sensor is triggered. As the box is moving at a constant speed of 4 inches per second, the distance can be divided by the speed, and it is found that it will take 1.5 seconds. As the box never actually stops moving, the plate has to be at the top of the box right as it is centered so that it will make it into the box. The plate needs to fall about 10.4 inches in order to reach the top of the box. This distance can be determined by using the measure tool and measuring the distance from the top of the releasing plate to the top of the box. The box is falling only under the force of gravity, so the equation of motion shown can be used in order to determine the time it takes the box to fall. The box has no initial velocity, as it is resting on the releasing plates. The value of t can be solved for, which results in a time of 0.232 seconds for the plate to fall. Final delay can be calculated by subtracting the time it takes for the plate to fall and the duration of the step from the time it takes the box to travel the 6 inches. This results in a delay of 0.72 seconds. For the fourth task's delay, the same process can be used. The travel time of the box will be the same as found before, along with the time it takes the lid to reach the top of the box. This is because it falls the same distance in order to reach the top of the box. The value that changes is the duration of the step, which is 0.65 seconds. Subtracting this and the lid fall time from the travel time of the box results in a delay of 0.62 seconds. With the study calculated, the study can be run to double-check the results. The playback speed can also be increased by going under the drop-down menu shown and selecting a new speed. Data from this simulation can be plotted by selecting the Results and Plots icon. For example, the vertical velocity of the plate can be plotted. Select Displacement Velocity Acceleration from the first drop-down. In the next drop-down, select Linear Velocity. From the third drop-down, select Y Component. Finally, select the top face of the lid and click OK. In the plot, you can see 3 spikes in the velocity. The first one is initially when the study is run. This is when the plate drops from the original mated position to the top of the releasing plate. The next spike is when the plate falls into the box. During this time, it reaches a maximum speed of about 111 inches per second downward. As it hits the bottom of the box, it bounces up with a positive y velocity before settling. The final spike is due to the box assembly moving on the spring plate. This data can also be exported by right-clicking the chart and selecting Export CSV. The data can then be opened in a program such as Excel. Other values can also be plotted. By using some simple physics, a lot of time can be saved when trying to determine the timing of the machine. The alternative would have been to guess values and run the study to see the results. The new values would have been chosen and the whole process would have to be repeated. This could be a very lengthy process. Even though this was a relatively simple example, hopefully you found it helpful and try to utilize SolidWorks Motion with your own projects.